Okay, today we're looking at the SKYRC X2204 KV2300 quad motor pack from gearbest.com. At the time of recording, these were just under $32 US for the set with free shipping, so that puts them a little under $8 per motor. For that, you get two clockwise and two counterclockwise motors. Really what that means is two of them have reverse threaded prop nuts and prop shafts, and that's denoted by the different coloured prop nuts. They come in a reasonably sturdy cardboard box, so if we flip around, we've got some specs on this side. They're 2300 kV, max of 18 amps. Curiously, they only specify 2 to 3 cell lipos. I'm pretty sure these were on fine on 4, but I'll check that when I'm doing my thrust testing later on. They have a 3mm motor shaft. They weigh 28 grams. They're 30.5mm from the very bottom of the base to the top of the prop shaft. In practice, they'll be a little bit higher because of the prop nut, but height's usually not a concern in quadcopters. And they're 28mm in diameter. We open them up. The very first thing you'll notice is there's one missing. That's because it's already in my thrust testing stand, which is something new I'm trying. You'll see that a little bit later on. Next thing to note is they're surrounded on all sides by this protective foam, which is nice to see. Some cheaper motors, sometimes I'll just ship in a plastic bag in a cardboard box and they can get beaten up when they're being transported, so that's pretty nice to see. Pulling them out, you'll see the different coloured prop nuts. Just denoting the different threading on these two. But SKYRC have actually taken it a step further. I don't know if you can see this on the video, but they've printed the directions of the motor bells on the bells themselves, just to try and help you get them on the right corners of the quad and help you when you're putting props on and what have you. So as long as you set them up correctly the first time around, all the prop nuts will be self-tightening, and that's all good. And really nice thing I like also is they've recessed the motor shaft completely into the base. There's no protrusion at all, so you don't have to worry about the center hole in the end of your arms being big enough. Next thing on the bottom, we've got our standard 1619 mounting pattern, M3 threads. But one thing they've done, they've put cooling ports directly adjacent to all of the mounting holes, so you can actually see really easily how deep your mounting screws are penetrating. This one's probably easy to see. So that you don't hit the stator. It's a common issue. People run screws that are too long and run into the windings, short out their motors. So that's really cool. That's nice to see. They've got 20 AWG wires, so good for a little bit of current. I guess we'll have a quick look at the length of the prop shaft. Looks like about 10mm exactly, so even with a reasonably thick hub, you still get a couple of threads on there. Yeah, that's decent. Interestingly, they don't seem to run a set screw to hold the motor shaft in. I'm not exactly sure what's going on there. We'll pull one apart and have a look. I'll get that out of the way. So there's just your standard circlip on the bottom, and then a washer. So if we just pop that circlip off, we should be able to take the bell off and have a look. Alright, so I've taken the circlip and washer off this one, so we just pop the bell right off. Interestingly, there's another circlip holding the motor shaft in, so I'm wondering if maybe they've pressed the motor shaft, if it's one piece with the prop shaft, and they've pressed that in from the top. Yeah, it's an interesting design, but I mean, shouldn't be any weaker than anything else out there. Windings look good. No real complaints here. I guess we might cut here and go to some thrust testing. Alright, so this is my thrust testing setup. We start out with a servo power supply. It basically acts like a really high C LiPo, supplies up to 47 amps and doesn't sag very much under load. If we follow it along, we've got a combination meter, amps, volts, amp hours and watts. What we're really concerned in is amps and watts, but it's good to have the voltage there as well. Follow it along, we've got the speed controller. Off that, we have our servo tester, which just controls the speed of the speed controller, and there's a power supply for that independently going off to there. And then we've got the scales, just to measure the thrust, and the thrust testing stand that you saw earlier. So it's sort of a, I don't know, tapered thing, just to try and get nice clean air up to the prop, or as clean as possible. And then the prop just pushes down and gives us a weight reading on the scale. Right, here are the results of the 3-cell tests. We've got thrust in grams along the x-axis and power in watts along the y-axis, so lower lines are going to be more efficient props, basically more thrust for less power. We'll actually start on the low efficiency side, so the upper left-hand side with the dark blue and orange, which are actually the 4-inch props. You'll notice they've sort of grouped themselves together, and that's because smaller props are, just because of physics, less efficient than larger props at moving air. But obviously if you're limited by your frame size, maybe you can only run 4-inch props, so this motor actually still produces a pretty decent amount of thrust, regardless. We get about 400 grams of thrust out of the Gemfan 4045 bullnose twin blade, and 460 grams out of the Dell T4045 bullnose. So it's still pretty respectable, but obviously if you want better flight times, and if you can run 5-inch props, it's better to do that. Our most efficient, so the longest flight times are the Gemfan 5030x2 in gold right down the bottom. Obviously, you're not getting the most maximum thrust out of that. That's a trade-off though, for the longer flight times. If you are looking for more thrust, the most thrust was actually obtained from the Gemfan 5045 bullnose at 560 grams. Versus only 440 out of the little Gemfan 5030x2. So it really depends on what your priorities are, but all across the spectrum, the motor delivers decent thrust without drawing too much power. I'm suitably impressed. We'll have a look at 4-inch props now. As promised, I did some 4-cell testing too. You'll notice that the lines aren't quite as clean as my 3-cell tests. I put that down to the fact that I don't have a high current 4-cell equivalent power supply. So I was actually using a couple of 4-cell batteries in parallel with a lab power supply to try and keep them topped up, but the voltage still did vary a little bit more than in the last test, so I think that's why our lines are a little less clean. But it's still a pretty good example of what the motor's capable of. If anything, you can get more out of them with a better power supply. You'll notice we've still split up into the 4-inch and 5-inch camps. We still got decent thrust out of the 4-inch props, but obviously you're never going to get as much as the 5s. We got 530 grams out of the Gemfan 4045 bullnose, the twin blade, and 630 grams out of the Dell T4045 bullnose, the tri-blade. I'll actually come back to that because, as you can see, it drew quite a lot of power. Not really ideal. Moving on to 5-inch props, the Gemfan 5030x2 also produced 630 grams of thrust. It's in yellow down the bottom, but only drew 200 watts. So it was drawing 2/3 of the power that the little tri-blade was, and producing the same thrust. So yeah, it's a much more efficient prop. Moving along to the Gemfan 5030x3, it's an interesting case. Over about 400 grams of thrust this time, it would just make a weird high-pitched noise, and the thrust would fall off, and it was behaving really strangely. So I don't know if there's some weird aerodynamic effect or what's going on, but yeah, it really didn't like the 4 cells. It's actually the old style of tri-blade, very thin prop, so maybe newer, thicker ones would be fine. Like the little Gemfan 4-inch prop had no trouble, so I'm not really sure what's going on there, but yeah, I couldn't get a full run out of it. The Gemfan 5045 twin blade produced 700 grams of thrust at 275 watts, so a bit of power, but still respectable. But the real star of the show is the Gemfan 5045 bullnose, producing 740 grams of thrust. It was drawing 18.5 amps, which is half an amp outside of the spec, but I think if you're just doing it occasionally, it might not be so bad. Unfortunately, it and the Dell T4045 bullnose, the tri-blade, drawing very high currents, makes the motor reasonably hot. Now, I'm not sure where the failure point is. I don't know how I would feel running either of those at very high throttles for long amounts of time. But perhaps in a real-world setting where you've got airflow coming past, Maybe it would keep them cooler, I'm not sure. But for the rest of the tests, I'd be more than happy to run any of the other props all day on 4 cells on these motors. They were between cool and warm, and yeah, totally fine, even in the testing environment. So yeah, I'd call that a win. I'd say you could definitely run 4 cells on these. Yeah, thank you very much for watching.